Now we will discuss some types of reflection. So basically, reflection can be broadly classified into two types. One is the regular reflection, the other one is the diffuse reflection. Let's bring out the essential difference between these two. Regular reflection takes place on an optically plane surface. It takes place on an optically plane, smooth surface. What I mean to say is that optically plane smooth surface means like a plane mirror where there are no irregularities. While on the other hand, diffuse reflection, it takes place on a surface which is not optically plane. Not optically plane or smooth, like wall of a room or a newspaper, the surface of a newspaper. If you see its surface closely with the help of a microscope, then certain irregularities in the form of tiny hills and depressions will be found. So if the light is incident on such a surface, then the reflection that will take place will come under the category diffuse reflection. Right? I'll show it diagrammatically. So basically, regular reflection, it takes place on a plane smooth surface. You can imagine this white board which is made up of plywood. It can be sunmica, it can be considered to be a plane smooth surface. While on the other hand, if you consider the wall, it has got certain irregularities, it's not perfectly smooth. So it is somewhat like this, having small depressions and elevations. So irregular surface, right? Naked eye, it can be imagined as if it is also smooth, but on a microscopic view, it will appear to have certain irregularities as shown in the diagram. So in the regular reflection, if a parallel beam of light is incident over here, like this, it's a parallel beam of light. It will get reflected as per the phenomenon of reflection and it will obey the laws of reflection. So it will get reflected like this. So what is happening over here is a parallel beam of light is incident over it. And after getting reflected, we obtain a parallel reflected beam of light going in a particular direction. Only this region or portion of the medium will get illuminated. So here, at each point, these are the normals. The angle of incidence at each point on the surface is same. These are the angle of incidence. Similarly, the angle of reflection at every point on the surface are also equal, obviously obeying the laws of reflection. So here, if a parallel beam of light is incident, then a parallel reflected beam of light is obtained. So the light gets reflected in a particular direction. Now here, suppose what happens is a parallel beam of light is incident. Suppose it's a parallel beam of light. Here what happens is the light will get reflected in virtually every direction. Suppose you draw a normal over here. This angle would be obviously equal to this angle. This is I1, this is R1. I1 would be equal to R1. Over here, the angle of incidence will be different. This is I2. This is R2. These two angles will be equal. Here again, if you draw a normal over here, this angle of incidence would be different. But angle of incidence would be equal to angle of reflection. So basic difference, you can very well judge this diagram. Over here, at every point, the angle of incidence and hence angle of reflection gets us different. Because the surface is not smooth, it contains certain irregularities. So what happens is, although laws of reflection at every point is valid, but angle of incidence and hence angle of reflection at different points is different. So what happens is the light gets reflected in virtually all the directions, not in a particular direction, it gets reflected in virtually all the directions. So that's the basic difference. In the case of diffuse reflection, when a parallel beam of light is incident over it, so the rays get reflected in virtually every direction. But the point to be noted is that in both the scenario, whether you are dealing with regular reflection or diffuse reflection, the laws of reflection are valid. That is, the angle of incidence would be always equal to angle of reflection. Also, the incident ray, the reflected ray and the normal all will lie on the same plane. Right? So, importance basically. Diffuse reflection has got a lot of application. Actually, a soft illumination is produced in the room. That is due to the diffuse reflection of light from the walls of the room. It is only due to the diffuse reflection that we are able to read a newspaper, or you are able to see the text or the diagram which I am drawing on this board. It is only due to diffuse reflection. In case of regular reflection, the object will either appear dazzlingly bright or it won't appear, it will appear dark, because the light will get reflected in a particular direction with great intensity. Here, a soft illumination is produced. So, that's the basic difference between regular reflection and diffuse reflection. We can also discuss some other examples as well. Like reflection by a plane mirror. So first we will draw the diagram of the image obtained in the case of plane mirror. Then we can discuss the nature of the image obtained in the case of a plane mirror. So this is the plane mirror. Suppose this is the object. This is the object. Now, as I have told you, the ray will be coming from the object and will get incident on this plane smooth surface. This is the case of normal incidence. It is the case of normal incidence, where angle of incidence is 0. So, the ray, after certain reflection, will retrace its path in the opposite direction. This we have discussed. Here, angle of incidence is 0, so angular reflection will also be 0. This is the object. At this particular point, the ray is incident in an oblique direction, so it will get reflected in the same medium, owing the laws of reflection. If you draw a normal over here, this angle obviously would be equal to this angle. Angle of incidence would be equal to angle of reflection. So let's consider some third point. Over here, if you draw a normal, and in this case the angle of incidence will increase, so angular reflection will also get increased. This will be the angle of reflection. So these are the 3 points where the rays from this particular object are assumed to get incident on this plane mirror. And these are the 2 rays which will enter the retina of the eye and will give us the sensation of sight. So where the image is obtained, that is what our objective is. So what to do is produce these lines in the backward direction. Behind the mirror there is nothing. So it has to be represented by dotted lines. Real lines are represented by dark lines. Dotted lines signify imagined lines. So whenever drawing ray diagram, it is the case of drawing lines behind the mirror, imagined lines. It has to be represented by dotted lines. So if you produce this line in the backward direction, you will get a point of concurrency. Point of concurrency means all these rays will appear to meet at a particular point. This is the point of concurrency. These 2 rays, on entering the retina of the eye, it will appear as if these 2 rays are coming from a point somewhere over here. This is the point where the image of this particular object is obtained. So these are the 3 lines which are drawn behind the plane mirror, so it has been represented by dotted lines. Right? So the nature of the image. If the diagram is perfectly okay, then you can easily check. If this distance is x, this would be also equal to x. That is, the distance of the object placed in front of the mirror is exactly equal to the distance of the image formed behind the mirror. So that's the first property of the image formed in the case of a plane mirror. Second, the image is formed behind the mirror. Obviously, it can't be obtained on the screen. Therefore, the nature of the image is virtual. Then, the nature of the image is erect. If you stand in front of a plane mirror, our erect image is obtained. So, virtual and erect. Third, very important property. the image is laterally inverted. What I mean to say is that if I hold a pen in my left hand, then my image will show the pen to be held by me in my right hand. So basically lateral inversion means inversion sidewise. Lateral means side. So sidewise inversion, that is known as lateral inversion. So the image obtained in the case of plane mirror is always laterally inverted. Next one is, the size of the image is found to be exactly equal to the size of the object. So the linear magnification, which you will discuss later on, which is defined as the ratio of the size of the image to the size of the object, it is always equal to 1. Because size of the image is always equal to the size of the object. Suppose the object is considered with this pen. Its image will be obtained like this only. It will be of same size and it will be erect. This will be inverted, but its image will be erect. So again I am repeating the nature of the image. Nature of the image in the case of plane mirror is virtual, erect. Image is formed behind the mirror. The distance of the image formed behind the mirror is exactly equal to the distance of the object placed in front of the mirror. And the image obtained is laterally inverted. That's known as lateral inversion. And the size of the image is always equal to the size of the object.